Hello, everybody. I'm waiting for students to show up after I logged in again. A frustrating technology day, but we'll get through it. All right, we got one guy. And it looks like we're going to do Winter 19 Test 3 Part 4. Hope the audio is good. And we're going over to our other screen. All right. So here we go. Winter 19 Test 3 Part 4. We're starting with a hydroboration. You might be concerned what R is. I suggest you stop being concerned because it doesn't change from here to being 2 R's on B, or here, or here, or here, or at the end. So R could be anything. It does not matter. What does matter is that the pi electrons you choose need to attack the less electronegative boron. Oh, here we go again. Let's try that again. Okay, let's try it a third time. Wow. Okay, pi electrons. Attack boron. The electrons in the sigma bond between B and H go to the more substituted carbon. That puts a bond between hydrogen and the more substituted carbon, and that arrow looks awful. And that gives us the result with hydrogen on the more substituted carbon. So it narrows it down to product 1 and product 3. Product 1 is the only correct one because if you look at the mechanism you just did, both the bond to B, which was created with this arrow, and the bond to H, which was created with this arrow, happen at the same time. That's called syn addition. Syn addition results in this product. Now it's time for the oxidation step. And we already know that this product is wrong because in the oxidation step, the bond to B gets replaced with a bond to O. Oh, don't have to circle that other product. It's also created. But in terms of the alcohols, that's the major one. And yes, you do make this one as well. That there is a hint for you about what you do during an acid-base step at the end. So oxidation involves 6 steps. Step 1 and step 6 are acid-base. Hydroxide picks up a proton from hydrogen peroxide. And hydrogen peroxide becomes, oh wow, that was the biggest lag I've ever seen. Okay. In step 1, we get the peroxide anion. OOH. This is the first time you generated an oxide anion. This time and the next time, you will do the same thing with the oxide anion. You will attack boron. You will be making a 4th bond to boron. This is step 2. Step 2. We're going to make this. And I don't need to see wedges and dashes during the mechanism. You have a new bond to O, which has a bond to O and H. Make sure you show the OO bond at this stage. Don't forget, boron with 4 bonds is an anion. Yes, boron alternates between a 0 formal charge and a minus formal charge. Next step, it will be 0. Step after that, it will be minus. Step after that, back to 0. The third step is a rearrangement. That's where the carbon ends up bonded to oxygen instead of boron. The carbon boron bond breaks and becomes a carbon oxygen bond. Hydroxide is kicked off, which is another oxide. You're going to do the same thing with this oxide that you did with the peroxide oxide. What's it going to react with? It'll react with the other product. Here's the other product. We now have a bond to O. A bond to O from the C. Make sure that's clear. That's a C. That looks terrible. Slightly smaller dots. Okay, now it's a bond to O. And the O is still bonded to the boron. And the boron is down to 3 bonds as promised. Hydroxide will come and attack the boron. Hey, I'm having less trouble if I use the mouse. Maybe that's the way to go. All right, step 4. I want to keep everything on the same page here. Shrink down just a little. I think we can do it. Step 4, you're going to get a 4th bond to boron one more time. Got a bond to O. Okay, thank you. Bond to O. And a bond to B. With 2 R groups. And you also have a bond to hydroxide. We've lost track of our number of steps here. Yeah, we did step 4 earlier. We're about to do step 5. And remember, the combination of step 4 and step 5 puts an O on boron. The reason to do that was to get the other O off of boron. The other O comes off of boron. Setting up our acid-base step for step 6. Make sure you show the bond between the H and the O, because it needs to break in the acid-base reaction. R2. And the conjugate base of your circled organic product is the other species here. And what do we got? We got that. We got an O minus right there. Acid base makes that. Okay, let's use the mouse. There we go. And step 6 creates our 2 species. This one, and at the same time, that one. And that's the end of that, but we haven't done any explaining. Give a mechanism that accounts for the only, oh, it doesn't ask for explaining. Yay, happy times. So we don't have to explain in this particular one. That's step 6 was acid base. Step 1 and 6, both acid base. Now, do we have any questions about this one?
No.
Was the audio halfway decent on this time?
It wasn't bad.
Okay, good. screen was a little less glitchy, but not perfect. Maybe I'll try cleaning my screen. I don't know. What do we, I think we can sneak in one more. You said you had something in mind, Mr. Arbid, I'm pretty sure. Or maybe that was this.
Yeah, that was that, but I can look for another question. It's not a problem. I mean, the more help, the better, you know?
Of course.
Okay, I can look for another problem. Do you want to end and then restart, or do you want to find the problem first?
Let's end and restart. No, I can come right back because I can. So I'll be right
Okay.
back.
Yeah, no problem.